The other strand, which contains the complementary base sequence, is the template strand.
This is from Oxford College, that's why he sounds British, because he is British.
So what's the key features of the coding strand? The start of the coding sequence is known as the transcription start site. To the 5' side of this site is the promoter region. The promoter region contains particular DNA sites known as core promoter elements. These are important in the assembly of the complex of proteins that are needed to initiate transcription. This complex is called the transcription initiation complex and contains the RNA polymerase II enzyme along with additional proteins or protein complexes known as transcription factors. Transcription factors help RNA polymerase to locate the promoter and initiate transcription. We'll now consider how the initiation complex assembles. The first step in the assembly of the transcription initiation complex is the binding of the transcription factor TF2D to the TATA box, which is one of the core DNA promoter elements. TF2D is a complex of proteins and contains the key subunit.
So like this, you don't need to know. I don't have panic mode going, we need to do a TFID and what, no. Do I know the data box? Yeah. Data box is a series of TAs, that's the beginning of the promoter region and the 5' end, okay? But I've shown you on this purpose to show you actually a little more detail of what's going on to give you an idea, but just pick out the things that you recognize from the text in your notes as we go through this.
Unit that binds the TATA box. This key subunit is known as TATA binding protein, or TBP. The TBP subunit induces profound bending of the DNA. Binding of TF2D is followed by the binding of TF2A and TF2B. TF2B binds to the core promoter element called the BRE, as well as contacting TF2D.
Isn't that crazy? Just get that
In the
thing out
next
there.
step, the RNA polymerase II core enzyme is recruited together with TF2F. Finally, TF2E and TF2H are recruited to form the complete transcription initiation complex. This is the closed complex, meaning that the DNA is still double-stranded and the template strand has not yet been exposed. Transcription begins with a separation of the two DNA strands to form the open complex. This separation depends on TF2H, which uses energy from ATP hydrolysis to unwind the DNA and promote strand opening. The short stretch of DNA with unpaired strands is called a transcription bubble. The opening of the transcription bubble exposes the template strand, which will be used to form a complementary RNA strand. Free ribonucleoside triphosphates enter through the funnel region of the RNA polymerase and form base pairing interactions with the template strand. RNA polymerase.
So that's the A's and the U's, and they come up through this little hole. They get sucked in there, and then they start getting paired in.
Catalyzes the addition of nucleotides to the 3' hydroxyl of the last base in the growing chain. This means that the RNA grows in the 5' to 3' direction.
Doesn't change.
Transcription initiation does not go smoothly. RNA polymerase typically will start to synthesize the RNA, but the RNA product will diffuse away after it has reached a length of just a few base pairs. The whole process of synthesis then starts again. This process is known as abortive initiation. After multiple rounds of abortive initiation, RNA polymerase breaks free of the promoter and continues to synthesize the RNA in a more persistent way. This phase is called promoter clearance. RNA polymerase now forms a stable complex with the DNA and continues to synthesize the RNA. At the same time, TF2H phosphorylates the C-terminal domain of the large subunits of RNA polymerase II. This domain is called CTD. This phosphorylation of CTD is key to the processing of the RNA to produce the mature transcript. And this is what happens next.
Let's just stop there.
Sure.
So you got this nice initiation, elongation, termination phase. What we see is I like showing this video is holy crap. I mean, first of all, who figured this out? Okay, we named all these proteins and figure out exactly what each one does. And understand that when they first start with the mRNA, they actually can't do it right, so they gotta abort it like 3 or 4 or 5 times until they finally get it to roll and get it to form, and then polymerase can work on its own as you go through it. Okay, but the idea is again, what I liked about this video is showing how it opens up splits. It's not like replication where we're opening up the whole thing, the whole bubble's going. Here it's just a very small section of the DNA that we're opening at any given time to start forming that mRNA that's coming out, okay? You You guys did a nice job. The Tata box, again, what's the purpose of the Tata box? Purpose of the Tata box is to show the transcription initiation factors, all those T proteins. They were talking about where do I start the process, all right? On the promoter region, here's a Tata box, I recognize it. I'm gonna grab RNA polymerase 2, bring it over, and now we're gonna start this process right here, because that's the purpose of it. All right? Questions on that? An initiation, elongation, we're just doing our base pairing rules, A,